Imagine. You are in one fine morning, walking on streets. Suddenly the sky is burning down. You started to feeling very high temperature. The temperature is like standing on sun. The world's great mass extinction started happening. But this extinction only takes few seconds to destroy our Earth. The reason behind for this extinction is gamma ray burst. Hello everyone. Welcome back to our channel, Hidden Rays. To understand gamma ray burst, first we have to understand, what is gamma rays? Gamma rays are a type of electromagnetic radiation. In electromagnetic spectrum, starting with radio waves, which possess the longest wavelengths but it possess low energy. Slightly shorter are microwaves, moving towards the middle of the spectrum, infrared radiation. Visible light, the portion visible to the human eye, as wavelengths decrease, energy increases. Ultraviolet radiation, furtherly the wavelength decrease ended in X-rays and gamma rays. Gamma rays with the shortest wavelengths are produced in nuclear reactions and offer insights into the universe's most energetic phenomena. Gamma rays are indeed harmful to living organisms in excessive amounts. They are a highly energetic form of electromagnetic radiation and can penetrate most materials, including the human body. Prolonged or intense exposure to gamma rays cannot change human as Hulk. In actuality, exposure to high doses of gamma radiation would be extremely harmful and potentially fatal to a person. A gamma ray burst, GRB, is a tremendously energetic and short-lived burst of gamma ray radiation. This lasts for only a few milliseconds to a few minutes. In those seconds, it released high amount of gamma rays. These bursts are among the most energetic events in the universe, releasing more energy in a few seconds. Comparatively, it's more than our sun will emit over its entire lifetime. The first gamma ray burst, GRB, was discovered serendipitously during the late 1960s by instruments aboard U.S. military satellites that were designed to monitor compliance with the Partial Test Ban Treaty. The Partial Test Ban Treaty, also known as the Limited Test Ban Treaty, is an international agreement aimed at restricting the testing of nuclear weapons. These satellites were equipped with gamma-ray detectors to detect potential nuclear explosions in Earth's atmosphere. However, instead of detecting nuclear tests, they began picking up mysterious bursts of gamma-ray radiation originating from deep space. The first widely recognized detection of a gamma-ray burst occurred on July 2, 1967. The Vela satellites, part of the U.S. Vela Hotel program, detected a burst of gamma rays that appeared to come from beyond Earth. The nature of these bursts puzzled scientists, and their extraterrestrial origin was confirmed when it was realized that the bursts were not associated with any known atmospheric or terrestrial phenomena. This discovery led to the realization that gamma-ray bursts were a cosmic phenomenon, originating from outside our galaxy. The unexpected detection of gamma-ray bursts by the Vela satellites led to a new field of astrophysics focused on studying these high-energy and enigmatic phenomena. Since that initial discovery, significant advancements have been made in understanding the various types of gamma-ray bursts, their origins, and the processes involved in their emission. Dedicated observatories like the Compton Gamma Ray Observatory, the Swift Satellite, and the Fermi Gamma Ray Space Telescope have furthered our knowledge of these powerful cosmic events. Now, you all have curiosity to know about how gamma ray burst happens. But the exact mechanisms behind them are still being studied and researched. Two main types of scenarios are currently considered as the potential sources of GRB. Massive star collapse or long-duration GRB. The leading theory for long-duration GRB involves the collapse of massive stars. When a massive star reaches the end of its life, its core can collapse under its own gravity, forming a black hole or a rapidly rotating neutron star, pulsar. This collapse releases an enormous amount of gravitational potential energy, leading to the ejection of material at nearly the speed of light in a process known as a supernova. The interaction between the collapsing core and the surrounding material generates intense gamma-ray radiation. This scenario is often referred to as the collapsar model. Compact object merger or short-duration GRBs. Short-duration GRBs are believed to result from the merger of two compact objects, such as neutron stars or black holes. As these dense objects spiral toward each other and ultimately merge, they release a tremendous amount of gravitational energy. This energy can be converted into gamma-ray radiation through various mechanisms, including the acceleration of particles to extremely high speeds. The short-duration bursts have durations of less than 2 seconds, and the long-duration bursts last for more than 2 seconds and can extend up to several minutes. The maximum noted gamma-ray burst had the duration of 100 seconds. The actual number of GRB that occur each day in the observable universe is quite low. On average, there are about 1 to 2 GRB detected per day by space-based observatories with gamma-ray detectors. But all not happened in our galaxy, it happened in very distant galaxies. After the initial burst of gamma rays, there can be an afterglow phase, where the burst's energy interacts with the surrounding environment and produces radiation across various wavelengths, including X-rays, ultraviolet, visible light, and radio waves. This afterglow provides valuable information about the burst's source and surroundings. If a gamma-ray burst were to occur relatively close to Earth, well, it depends on the distance. If it is billions of light-years away, it would be harmless even though it points directly at us. In reality, these are the only cases of gamma-ray bursts that we can detect. But, the closer it is, the more harmful it becomes. If the gamma-ray burst is just thousands of light-years away, we'd be in big trouble. You see, these are radiation carrying extreme amounts of energy that could vaporize an entire planet instantly. If a nearby gamma-ray burst struck Earth, losing the atmosphere is the best-case scenario. Then, what's the worst? Well, if it was powerful and close enough, it could vaporize Earth immediately, killing the solar system's most expensive planet. But, there are always intermediate ones. If it is neither too close nor too far, Earth would absorb most of the radiation. The satellites would be damaged, so we'd lose our internet connection. But it wouldn't persist for long if astronauts get out to fix them quickly. Luckily, a gamma-ray burst damaging our solar system is highly unlikely since they have not happened for billions of years. However, the likelihood of a GRB occurring at such a close distance is extremely low, and there is currently no known threat from a nearby GRB. The intense gamma-ray radiation could ionize Earth's upper atmosphere, leading to changes in the ionosphere and potential disruption of radio and communication signals. Gamma rays can interact with molecules in the atmosphere, potentially leading to the depletion of ozone. Ozone depletion could have implications for Earth's climate and protection from harmful ultraviolet radiation. UV radiation can damage the DNA and other cellular components of living organisms, leading to higher rates of skin cancer, cataracts, and other health issues in humans. It can also harm animals, including marine life like plankton and fish, which form the base of aquatic food chains. UV radiation can disrupt the reproductive and developmental cycles of these organisms, affecting entire ecosystems. All electrical equipment will destroy and the satellites are started to falling towards Earth. If it has high intensity, the Earth fully destroyed, and the same time, if it has low intensity, the one side of the Earth completely destroyed. Auroras and light shows. The interaction between the gamma rays and the atmosphere could produce spectacular auroras visible at latitudes where auroras are not usually observed. But there is no any humans to watch these shows. It's important to emphasize that the likelihood of a GRB occurring close enough to Earth to have a significant impact is extremely rare. However, it might not be a comfort to know that some scientists posit that gamma rays might have played a part in the late Ordovician extinction about 440 million years ago. About 70% of all marine life died, and pretty much everything was marine back then. This was the second largest of Earth's major extinction events in terms of the percentage of life forms which became extinct. The period has a few of the hallmarks of an increase in radiation, like global cooling, that might point to gamma-ray zaniness. So sure, a gamma-ray burst could wipe out life on Earth. It might have even happened once before. But don't panic yet. Because no trace of GRB that will happen in next millions of years. We've got another 500 million or so years before it's likely to cause us much trouble again. But, whatever will happen, because this space has so many different mysteries. That's it for today's video. Thanks for watching. If you have any opinions about this video, comment below. And don't forget to subscribe our channel. Hidden Rees.